Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department. In this video, we are going to continue with the first unit of microcontroller and application, which is basics of microprocessor and 8051 microcontroller. In this video, we will study about the 8051 microcontroller as a Boolean processor. 8051 processor is a CPU that can perform some operations on a data and gives the output. The 8051 processor contains of a complete Boolean processor for single bit operations. The internal RAM contains 128 bit addressable and SFR space supports up to 128 other addressable bits. All ports lines are bit addressable and each can be treated as a separate single bit port. Bit addressable, that means the programmer can individually set or reset a particular bit through the programming. The 8051 instruction set is optimized for the 1-bit operations. The Boolean processor provides direct support for bit manipulation and testing of individual bits, allows the use of single bit variable to perform the logical operations. Therefore, 8051 can be used to solve the Boolean expression. Bits may be set or cleared in a single instruction. The bit addressing can be used to test pin monitoring or program control flags. The Boolean instructions are 1 byte, 2 byte or it can be 3 byte long. The example of instructions for Boolean function is given below. First is ORL P0, #1, that is set P0.0 bit. Then XRL P0, #1 to toggle the P0.0 bit. Then CLR, that is clear the carry bit. So these are the some example for Boolean instruction. Now next we will study about the power saving option of 8051 microcontroller. The 8051 microcontroller has two power saving options. First is idle mode and second is the power down mode. So first is the ideal mode of 8051 microcontroller. By setting the bit 0 in the PCON register, PCON is a program control register, the CPU forced into the ideal mode. In this mode, the CPU put itself to sleep by getting off its own clock. It does not stop the oscillator, it stops the clock signal of CPU. Since the CPU withdraws the 80 to 90% of chip power, putting it off, it saves a significant amount of power. The on-chip peripherals, that is timer, serial port, interrupt, etc., and RAM continue to function as a normal. The stack pointer, program counter, PSW and all other registers maintain their data during the ideal mode. In this mode, the signal ALE and PSEN bar are high. Due to this, the external EPROM is disabled. The port pin hold the logical state they had at the time idle mode was activated. Now these are the steps for termination from ideal mode of 8051 microcontroller. Activation of any interrupt will cause the hardware to clear the bit 0 in PCON register and terminates the ideal mode. After execution of an interrupt service routine program, execution will resume in main program. Second option is hardware reset, that is signal at RST pin clears the ideal bit in PCON register directly. At this time, the CPU resumes the power execution from where it left off. Now next power saving option is power down mode. By setting bit 1 in PCON register, we can force 8051 in power down mode. In this mode, the CPU puts whole chip to sleep by turning off an oscillator. Suppose the CPU running from external oscillator, then it gets of a path to the internal clock generator so that no internal clock is generated. The on-chip RAM saves its data as long as the VCC is maintained. In this mode, the signal ALE and PSEN bar are low, hence power is removed from rest of the circuit. The port pin continues to output the data which was returned to them. Now the termination from power down mode of 8051. First, the only exit from power down mode is a hardware reset. Since the oscillator was stopped, the reset signal must be held active long enough for oscillator to restart and stabilize. Reset initialize all the SFR to their reset value and restart the program from location 0000H. Reset does not affect the on-chip RAM. Now next topic is derivative of 8051. So these are the devices like 8051, 8951, 8952, 8031 and 8751, and on the basis of these parameters it will be compared. First is a on-chip data memory, then on-chip program memory, that is internal data memory, internal program memory, then number of 16-bit timers or counters, then number of vectored interrupts, then IO ports and full duplex serial IO ports. Now 8051 has 128 internal program data memory, 128 bytes, 4 kilobytes of ROM, two 16-bit timers, 5 interrupts, 4 IO ports and 1 full duplex serial IO port. 8951 has 128 on-chip RAM, then 4 KB on-chip ROM, then two 16-bit timers, 6 vectored interrupt, 32 IO lines and 1 serial IO port. 8952 128 bytes of RAM, 8 KB of ROM, 3 16-bit timers, 8 interrupts, 32 IO lines and 1 serial IO port. 8053 has 128 byte of RAM. There is no program memory, that is no internal program memory in 8031. Then two 16-bit timers, 5 interrupts, 4 IO ports and 1 serial IO port. 8751 device has 128 byte of RAM, 4 KB EPROM memory, two 16-bit timers, 5 interrupts, 4 IO ports and 1 serial interrupt. Next question is explain the various selection factors of microcontrollers suitable for particular application. So the selection of microcontroller depends on the type of application. The following factors must be considered while selecting the microcontroller. First factor is word length. The word length of the microcontroller is either 8-bit, 16-bit or 32-bit. As the word length increases, the cost, power dissipation and speed of microcontroller will be increases. Next factor is power dissipation. It depends upon the various factors like clock frequency, speed, supply voltage, VLSI technology, etc. For battery operated embedded system, we must use the low power microcontrollers. Next factor is clock frequency. The speed of the embedded system depends on the clock frequency. The clock frequency depends upon the application. Next factor is instruction set. On the basis of instruction set, microcontrollers are classified in two categories. First is CISC and second is RISC. The CISC system improves the software flexibility. Hence, it is used in the general purpose system. RISC improves the speed of the system for a particular application. Now, next factor is internal resources. The internal resources are RAM, ROM, EEPROM, flash ROM, UART, timer, watchdog timer, PWM signal, ADC converter, DAC converter. network interface, wireless interface, etc. It depends on the application for which the microcontroller is going to be used. Next factor is input-output capabilities. The number of I/O ports, size and characteristic of each I/O port, speed of operation of the I/O port, serial port or parallel port. These are the consideration needed to ascertain. Next factor is memory. For mass production of microcontroller, ROM versions, and for laser production, EPROM versions or CPU versions with external program memory is suitable. So these are the factors on the basis of which the microcontroller can be selected. Thank you.